中真的孤独吗？这是一个古老而深邃的问题，但今天答案或许正慢慢浮出水面，因为一位神秘的访客正在悄然接近我们的太阳。他的名字是 3IATLAS， 一个从遥远星际深处穿越而来的天体。它正以惊人的速度，每小时超过21万公里扑向太阳。而有一些大胆且备受尊敬的科学家，包括哈佛大学的阿维勒布教授，则提出了一个令人震惊的假设：这或许不是一颗普通的星际彗星，而是一艘外星文明制造的探测器。是不是听起来像科幻小说？但请等等，先别急着否定，因为这个天体的行为确实奇怪得让人挠头。几年前，我们首次遇见了第一位星际来客奥莫莫，他在2017年以异常的加速度掠过太阳系，引发了全球热议。紧接着2019年，第二位访客阿尔鲍里索夫由一位乌克兰业余天文学家发现。而如今，我们迎来了第三位旅者 3IATLAS。他的出现再次点燃了一个问题：这些星际来客真的都只是宇宙的路过旅人，还是说他们中某些藏着更深的故事？阿维勒布教授就认为 3IATLAS 存在诸多异常，难以用自然现象来解释。比如，它并不像一般彗星那样在靠近太阳时喷出典型的尘埃和水蒸气，反而缺乏水冰挥发，却富含二氧化碳，而且其轨道呈现出极度椭圆且逆行的走势，与大多数太阳系天体的运动方向背道而驰。这些特征让它看起来更像是被某种目的性设计出来的轨迹，仿佛是为了最大程度探测太阳系内部行星。
It's quite rare that there is an event or an object that attracts so much the public attention, and that's extremely important because science is fun. It's not about getting the Nobel Prize, it's about understanding nature. And I'll give you just two anecdotes very quickly. One, I received an email from a former US Air Force pilot who said, because of you, he was referring to me, my daughter is now excited to become a scientist, and she keeps speaking about aliens. And then a second anecdote, last night I get a text message from one of the racers at the NASCAR car race, and he says, I want to put an image of 3IATLAS, the object that we will talk about, and you on the hood of my car. And you are now a very hot commodity among car racers in NASCAR. And I'm planning to meet him actually within a few weeks. There will be a race in Vegas, and I hope to go there. But these are just examples of how much this object captivated the public's interest. And think about it, if CERN would have discovered the lightest supersymmetric particle, which we did not discover, I should say, and it would have been the dark matter, that would not necessarily inspire a girl to become a scientist, and or a NASCAR car racer to put it on the hood. So what I would like to say is that this is a rare opportunity, and that's why I wrote more than 50 essays over the past 2 months on medium.com that discuss how science is work in progress. We don't know what something is. We're trying to figure it out by using data and evidence. And that is a thrilling experience, in difference from politics, where you know the answer sort of in advance, and it has nothing to do with necessarily a way of vetting whether it's real or not. I mean, you just tell a story and try to become popular. So science is different. It's not about us. It's not about prizes. It's about figuring out nature. And the best approach is to be modest and say, we don't know, let's figure it out. Now, with respect to 3IATLAS, it was discovered on July 1st, 2025, by a small telescope, 0.5 meter in size, because it's bright. And if you translate its brightness, you find that it has to have a diameter of somewhere between 20 and 46 kilometers if what we are seeing is a reflection of sunlight from a solid surface. It's not obvious because you might argue maybe there is a cloud of dust. However, if there was dust around a much smaller nucleus, then the dust would be pushed behind the object by solar radiation pressure. We know that from comets. We see a cometary tail behind them. And the Hubble Space Telescope looked at this object on July 21st, took a very high resolution image. There was no tail behind it. We saw glow ahead of the object towards the sun. And I'm actually writing a paper trying to explain that. That was not seen before. It's sort of an anti-tail. Instead of a tail behind the object, there is something preceding it, ahead of it, towards the sun. But the other issue is that if it's such a huge, giant rock, the way that my colleagues are arguing, then it's 1,000,000 times more massive than the previous two interstellar objects that were found. An interstellar object is an object moving too fast to be bound by the sun. This object actually is moving at 60 kilometers per second relative to the frame of the galaxy nearby, and also relative to the sun when it entered the solar system. So it's really fast, and there is just not enough rocky material in interstellar space to give us such a giant rock once per decade. So either it's a very small rock surrounded by a lot of dust, but then why don't we see the tail? Or it's actually not a rock. And of course, in that case, it might target the inner solar system, and then the statistics has nothing to do with delivery of one rock per decade of such a gigantic dimensions. It's twice as big as Manhattan Island, if we believe the results from the SphereX data. Now, SphereX is a space observatory that actually inferred that there is a huge plume of gas around it containing mostly CO2, carbon dioxide, 95% by mass, 5% is water vapor. And that implies that it may not be a water-rich comet the way it was. And there was also some data from the Webb telescope that in fact inferred very clearly the dominance of carbon dioxide and no tail. But after that, we had some data from the Very Large Telescope in Chile that indicated that in the plume of gas, there is also nickel without iron. And you don't get nickel without iron except through an industrial process on Earth that produces nickel alloys, partly for spacecraft. And therefore, the question arises as whether this was technological in origin. The fact that there is only nickel but no iron observed. Now, the most interesting anomaly, I should say, besides the size of the object, is that the trajectory is aligned with the planets around the sun to within 5 degrees. That's a probability of 1 in 500 out of a random orientation. And in fact, the previous comet, Borisov, was at a very high inclination, very high angle relative to the ecliptic plane. But the good news is that on October 3rd, that's very soon, within a few weeks, the 3IATLAS, this object, would come within 29 million kilometers from Mars. And there is a camera there called HiRISE on board the Mars Reconnaissance Orbiter that could take a high-resolution image of it with a pixel resolution of 30 kilometers. And that would allow us perhaps to infer the size of the nucleus and settle once and for all this question of whether it's anomalous in its size, whether it's 1,000,000 times, why do we see an object that is 1,000,000 times bigger, more massive than the previous two? And
勒布甚至引用 SPHERX 和哈勃等望远镜的观测数据，指出其核心直径可能达到惊人的46公里，这是2I鲍里索夫的上百万倍之大。更让人费解的是，在理论上，如此巨大的自然星际物体应该早就被发现过，然而此前却未见踪影。那会不会这根本不是自然形成的？而且，当望远镜对它进行观测时，没能发现预期的尘埃云或彗尾，其散发出的光辉方向甚至与彗尾该有的方向相反，这现象被称作反尾。更奇怪的是，它释放的气体中含有镍，却没有发现铁，这与已知彗星中的化学构成极为不同。勒布指出，这种成分更接近于工业提炼金属时产生的排放。
So the Very Large Telescope detected a significant amount of nickel, but put only an upper limit, a quite large upper limit, on the ratio of nickel to iron. So in other words, there is no detection of iron, and that is very different from other comets where you see both of them together, because these two elements, nickel and iron, are produced in supernova explosions, exploding stars. And in fact, iron in the solar abundance of elements it has a higher fraction. And nevertheless, in this case, we see only nickel. And so one suggestion that was made by the authors of that paper was to say maybe there was a production of a preferred production of nickel through a carbonyl pathway. The carbonyl pathway is known from the industry. That's the path by which we produce nickel alloys. And nickel alloys without iron are very useful as the skin of spacecraft, for example. And so they mentioned in the paper that maybe nature follows the path that we are using industrially. We haven't seen that in other comets. I looked at the distribution, and in all of them, the iron to nickel ratio is of order unity, with some variations, but definitely not as extreme as in this particular case. So that's just another anomaly. I don't make a lot of it, but I'm just saying there are anomalies of this object. And I asked myself, will I be happy if it ends up being a rock? And of course I will be happy, because there is less risk for humanity, no threat. But on the other hand, I think humanity desperately needs a wake-up call. If you just read the news every day, our priorities are really do not testify that we are intelligent. We invest most of our resources in conflicts. That's what we tend to do. And instead of coming together and towards a more prosperous future for all of us, and perhaps just finding a threat in the sky would bring us together, because we would realize we're all in the same boat. That's one reason I think that will be good news if it ends up being technological.
而美国 NASA 的 TAS 卫星更是早在它正式被发现前2个月，就记录到了它在太空中的亮度变化。在短短4周内，其亮度突然增强了5倍，远超天文学家们的预测。这种突变式亮光到底是在响应什么？还是释放某种能量？ 3IATLAS 进一步观测发现，它在远离太阳、水冰难以升华的区域就开始活跃，而释放出来的主要成分竟是二氧化碳，其比例是水的8倍，创下了彗星观测史上的记录。而这种早期的活跃状态不仅少见，也非常不合逻辑。这说明它要么是在一个极端富含二氧化碳的星际环境中形成，要么是经过极为漫长的宇宙旅程，其表面成分已被宇宙辐射彻底改变，甚至有科学家猜测，它可能起源于银河系中最古老的恒星族群之一——后盘恒星系统。如果这一推测成立，那么 3IATLAS 携带的或许就是远古星系的冷冻物质，甚至比我们的太阳系还要古老，而这无疑是宇宙留给人类的一条时间胶囊。但科学界也并未轻易得出结论。虽然阿维勒布的外星科技假设引人关注，但大多数研究人员仍倾向于将其视为一颗拥有非典型成分的自然天体。
Yeah, so Congresswoman Luna did call me by phone and asked me for an update about 3IATLAS. I met her before at the briefing that I gave on May 1st, 2025 in the US Congress. And, I advocated for the scientific approach where she doesn't need to listen to storytelling the way that Michael describes, because stories, can be fabricated, and science is really our best hope. The method of science is collecting evidence. You don't need to listen to people. Just collect as much data as possible. And you can tell the difference between, a genuine scientist and a conspiracy theorist. The way to tell the difference is give both of them a lot of data. The conspiracy theorist will be very worried about it because it may go against the narrative. The scientist, a genuine scientist, will be delighted because even if it changes the view that that scientist had, we learn something new. So that is the process of scientific learning. Now, I'm not saying that practitioners of science, scientists, are all genuine scientists. Many of them are anti-science. They have a view, they have an echo chamber, and they want everything to conform to that. And so that's my problem with some of the scientists. But I should say, actually, that just last week there was a paper out saying we should look for technological signatures of interstellar objects. And I look at the author list, and in the author list, there are people who are attacking me personally on YouTube and on blogs. And I asked myself, how come? And then I remembered what Oscar Wilde said, that imitation is the sincerest form of flattery. Okay, so I don't mind as long as they say what I'm saying, that's fine. But what they're trying to do is basically say, if we happen to find technological signatures of an interstellar object, we want credit for that. This was discussed long ago. It's not about Avi. So they give me a hard time, but at the same time they want to diminish my prospects of getting recognized for saying that if it happens to be true.
毕竟，星际天体原本就来自多种恒星系统，其物理化学性质必然有别于本地彗星。无论真相如何，全球天文学界已经动了起来。NASA 与欧洲航天局纷纷开始构想专门用于追踪这些星际访客的快速响应探测器。例如，美国西南研究院提出的星际彗星探测器 S， 就是一个旨在以极高速度飞掠星际天体，收集表面与喷气数据的概念任务。这项任务将不会绕轨道运行，而是通过一次擦肩而过来获取关键信息，类似于快照式的捕捉这些转瞬即逝的宇宙旅客。未来的策略也正在发生变化，因为我们现在知道，像 3IATLAS 这样的星际访客并不罕见，过去他们或许每年都有穿越太阳系的机会，只是我们从未发现。而随着像维拉鲁宾天文台这样的高级望远镜投入使用，预计每年我们将能探测到数千颗小天体，其中一些可能足够接近以供详细研究。而这些努力或许将彻底改变我们